Yeah, we're live. How's it going, Jordan?
Woo. Going good. How are you?
Pretty good, bud. I we're here, man. We're doing it. We've been talking about it for a while, and it's time to look at the results of this patch that we've been teaming up on for the last
Yeah,
few
last
weeks.
few months.
Yeah, I guess it has been, and we've been thinking about it for a while and going back and
Yeah, yeah,
forth and Um, I think we should take a split second though and kind of like, set the tone, if you will. Um, so basically, like 5 years ago, I was like, we should make these changes, and kind of threw it into the void, and then we didn't really do anything with it. And you and I were having a conversation a couple months ago about some optimizations that could be done to the storage engine. And I was talking about, I think I put it in the context of EBS, like looking at how EBS performs, um, doing some performance testing on it, and basically looking at how Cassandra interacts with the file system. And we were kind of looking at how Cassandra does these like pretty tiny reads, like during the compaction process and during the streaming process. And on a system like EBS, we've got there's two knobs that you can turn. You've got IOPS and you've got throughput. And one of the things that I've seen over the years is if you turn your read ahead way down, your compaction throughput slows down, um, your streaming throughput slows down. And this has been with a whole bunch of different versions of Cassandra. Streaming side of things shouldn't be so bad anymore because of the zero copy streaming that we have now.
exactly.
The entire SSable streaming, but it leaves compaction. Compaction is a big deal. You can't really have slow compaction. So we were talking about it, and you were like, "Yeah, I think I can knock this thing out." Why don't you give us kind of a breakdown of what you found?
Yeah, absolutely. Yeah, it's a fun patch to work on. I was just looking back. You opened this ticket back in December of 2019. So what is that? 4.5 years ago. And like you mentioned, right? Like we don't really want read ahead on for Cassandra read performance because then you end up reading way more than what you want. Usually a partition fits in one chunk of a compressed file. And you had done some research, right, showing like how many small reads we were doing. But what we do want is we do want read ahead for compaction, and obviously at the kernel level, we don't have that level of control. We can't say like for these reads do read ahead, and for these reads don't do read ahead. So that's basically what the patch does. Is it knows when it's doing reads for compaction, and it simulates read ahead, but in user space instead of at the kernel level. So
Yeah, and
right
that's
now, the patch only reads it has one mode. It reads 256K at a time, which I believe you found is kind of like it's the max amount of bytes you can read in one IOP out of
yeah,
EBS.
yeah, exactly.
And you had done some research on, with FIO on the number of IOPS and the throughput. And I think throughput starts to taper off as you get close to the EBS's disk throughput that you've set. I think we have it set at 128 today.
Yep, yep,
Um, but the IOPS keep going down. And the thing about EBS is when you hit your IOPS budget, it throttles you. And we've seen that when you look at profiling of the disk
yeah,
using something like XFS dist or something like that. And that can really hurt your P99s. And so what happens with compaction is you have compaction running in the background and your latency is kind of going up and down and up and down
yep,
because you're eating into that IOPS budget and you're hitting the max. And kind of the easy solution to this is just jack up IOPS to the 16K maximum. But if you're doing enough IOPS to hit that 16K already, compaction's still eating into it.
yep,
And B, you're paying for those extra IOPS just to be inefficient with compaction. Um,
yeah,
so going back to the patch, Cassandra reads a compressed block at a time out of a compressed file. So if you had the default 16K chunk size and you have a 4-to-1 compression ratio, you're actually reading 4K at a time, which for a big file is a lot of tiny, tiny reads. And even if you're going like, let's say like there is a slight amount of read ahead on, or you've got the page cache on, and that file's cached in the page cache, you're still going back and forth from user space to kernel space, from user space to kernel space over and over and over again.
Yeah.
And so with this patch, we're going to do that one 256K read in one IOP. And then we're going to do those small 4K reads out of that buffer. And so the only thing we're doing is copying from user space over and over. And so that's briefly what the patch is doing. Right now, it only applies to compressed data files that are not MMAPs, which is how you should be running your Cassandra anyways. And we're going to get it working for the new storage format as well as the old one. But right now it works with the big table storage format, and we're going to make it work with BTI as well.
Yeah, I think to me, it's like important to kind of take a look at there's two really important factors there. It's not just about like looking at the EBS quota, although that is super important. Like there's a lot of clusters that are running on EBS now. It's like way more reliable than it was like 10 years ago when I used to get up and say don't use EBS. Now I've worked with a lot of people that use EBS because it's pretty reliable. But to your point, it can get really expensive if you are not efficient with your reads. Like, we looked at just like a 1 terabyte drive, GP3 configured with 3,000 IOPS versus 16,000, and it was like $80 versus $145. So you apply that to your whole fleet, and that's a monthly cost, and all of a sudden you end up spending like hundreds of thousands of extra dollars or millions of extra dollars if you're like a huge user on EBS just because of inefficiencies that you've managed to address in this patch. So it's not just the EBS side of things, though. It's also the system overhead, like going back and forth between user space and system space. Even if you're getting data out of the page cache, like reading out of a buffer, it's just literally like, hey, the bytes are here. Let's just copy some stuff over here, is way more efficient than reading out, going to the page cache. It's night and day difference. So because you still have to do the copy, but you're doing it between two different spaces as opposed to just
staying all in user space. Yeah, there's a non-negligible penalty to constantly going back between user space and kernel space.
Exactly. So to me, it's like even if we were to apply this to NVMe, and I still want to do some testing on the NVMe side of things, like I do expect that under like and I like to break stuff, like the way that I learn is I break everything, and then I figure out why it's broken. So I think that it'll be pretty cool to test this on NVMe as well. But today we're going to be looking at the EBS side of things because the difference is so massive, and for anybody running EBS, this is just going to turn into a massive cost savings for them. Be able to use lower IOPS, and maybe more importantly, more predictable latency, because
I think that's the big one for me.
Exactly. It's like if you know that compaction is going to chew through some number of IOPS, you're forced to then add more so that reads are not affected. Because when you hit that quota, they really do lock you out. Like it's like you're cut off, and then a second or two later, your request comes through, and you're like, great. But that's a really bad user experience, pushes your latency up really high. In fact, we're going to take a look at the let's jump on here because I have a cluster up and running. Let me start out though. I was going to jump right into my let's see, where is this? Is this it? Let me make sure I got the right dashboard here. I'm going to pull up. So I'm going to pull up my monitoring dashboard where I've got a whole bunch of useful stuff. This one. And I'll put us over here. No. Put us over here. No. Nope. Yeah, this one's okay. I'll do that.
Oh.
Oh wait, we have a comment. Recently discovered Cassandra cluster that was running on 72 gig ext4 GP2 single volume for entire disk. Mostly updates using materialized views, never upgraded in 6 to 7 years. Wow. Oof.
So much going on in that comment.
Matt, you are just rolling in with the hey, I have the worst setup possible. Yeah, all that stuff sounds bad, man. GP2, not great for production environments.
And what's interesting about GP2 is your IOPS scale with the volume size. So something as small as 75 gigs, you're not going to have a lot of IOPS. So again, like having a patch that is a little bit kinder with using your IOPS is huge.
Yeah. So let's look here. So we've got this is kind of interesting. So we've got CPU usage per host. We're only in the 30 whatever percent. But then if we look over here at load average, like this is pretty high. Like seeing load average in the 20s is really high. Average CPU wait per host, like there's just a ton of time spent waiting. So I'm just going to drop onto one of our nodes and let's take a look at this. Oops, and I think this one. Yeah, cool. All right. Wow, this is atrocious. So these numbers are horrible. I think I'm actually going to have to, this was working before. I'm going to have to slow this down. We can't even handle this EBS. Look at this. It was only set to 15,000 requests a second, and it wasn't working at all. Let's change that to 10K. Let's see how we do. Yikes. So the CPU usage, not even that high. We're just completely waiting on IO. In fact, when we look back here at this history, look at this IO wait, 66%. Like this is just
77, 80%.
Yeah. So these numbers are nuts. And probably I'm guessing a decent amount of this is coming from the compaction side. So if I look at compaction stats here, this is an unthrottled compaction, so I'm letting this thing just go absolutely nuts. There's a handful of compaction tasks, but like we're doing it, and so if I look here, I can see that we're basically coming pretty close to hitting our yeah, see, we're hitting our limit here. So we're definitely hitting the IOPS limit on these drives. But
do you want to move us to the right now?
Yeah,
to the terminal?
Yeah, there we go. Now we're in the right spot. Looking at these stats, we're seeing 35 megs a second on reads. Right. That's
and you can see right there that we're hitting that 3,000 IOP limit.
Exactly. Yeah, we're consistently hitting this limit. So we've got super high IO over here. Our latency numbers are terrible. Like our reads are okay, or sorry, our writes are okay. And this is
up, but
yeah, this is terrible. Like no one would want this. This is like completely unacceptable. In a lot of
I use Cassandra for sub 100 milliseconds, sub 200 millisecond, depending on the use case. A lot of times in the tens of milliseconds.
Yeah. Oh, Matt, we got an update. After I discovered it, they decided to upgrade GP3 and take no further action. Large amounts of async inserts to make it hurt. Yeah, man. Yeah. So
at least you're on GP3 now.
Yeah, it's significant improvement, but it's going to be it can get expensive. Like if you have a high write throughput. I mean, this isn't even a high write throughput. I'm doing 10,000 requests a second. I've in a like an NVMe environment, I remember when I was testing try memtables, I was getting 100,000 plus requests a second against a 3-node cluster, or 100. I think it went up to like 160,000, maybe against a one, or maybe it was one node. I forgot, but 10,000 requests a second should not be difficult for Cassandra. But we're spending so much time in IO just chewing through it. So I think we can already conclude that like this doesn't look good. Like this is pretty much, let's just call it bad. So what I'm going to do here, so just in case folks don't know, I want to point this out. So Jordan and I have been working on this Easy Cast Lab tool for a few months now. I think we've put a lot of work into this thing, and one of the reasons why I like it, one of the things that we have that's like really cool is it bakes an AMI. So it's actually a fork and a rebrand of my original TLP cluster tool. And the thing that's cool about it is all the Cassandra versions are baked in. So if I kill this and then I just look in here, I can see that like there's a bunch of versions. And this is yours, right? 14.542?
Yes.
Yeah. So what we can do is we can stop Cassandra. Okay, so I'm going to stop Cassandra here, and then I'm going to switch versions, and I'm just going to bring in the same config file that we were using before because it's the same. There's no reason not to. So then we have another command that we can just say use Cassandra, and we just pass the new version. I don't know why I need to make it run as root. Silly. So we are going to just say, oops. So we were running 5.0 head, and this was actually built last night. So we're not even talking about like an old version or something like that. Like it's easy enough to build new versions and build the AMI that you and I run this like every day basically. Like I'm always testing the latest.
Yeah, especially when you have the way that we have it split out now between the base package, it's really easy to build the Cassandra package in like 5 minutes. So just always get a fresh build.
Exactly. So okay. All right, looks like Cassandra is not running. I guess I could have done my although I never remember that that's there. So let's just go ahead and restart this. Okay, so now we're just watching the log file, and hopefully things are going to start up. Hopefully I didn't just go, because I haven't done any practice or anything. I just kind of winging it, hoping things work.
Doing it live.
Yep. Doing it live, everyone. Don't know what's going to work. All right, so we're up. So it's the same config as before, same data files, same everything. Just different version. We can verify that when we look here. Oops. So when we look in user local Cassandra, we can see that current is pointing to your custom build. So that's defined here. So if anyone is interested in that patch, there it is. What else we got? I guess let's just hop back in here and take a look at. We were looking at this before. Sorry, we were looking at IOStat. So let's just go bring up back IOStat. Okay, so these numbers are a little bit higher than they were before. IO weight is looking a little higher. Did we?
The throughput is. I wonder if we're throwing so much traffic at it that we're not seeing because we're just using all the IOPS, but throughput's much higher. We went from 30 to 60.
Yeah, that's true. So let's just run it here. We'll do that. #DM1. Okay, so now we got it on both boxes. So this is Cassandra 2 and 3. These are our controls, and we've got the patch version over here. And look at that, it's still throwing a bunch of errors. So, whoops. Okay, so now we're seeing that we're still hitting this. Is this higher? Let's figure out
It
if we're
was when you.
and let's just let's make sure that we're actually getting it. Oops. No, we're gonna, because we actually want to check for compaction. So let's just filter this. Right. So we'll just get the compaction side of things. And oh yeah, I need to pass in a number here. So let's just, since we are seeing high IO weight still, let's just take a look. Let's do everything for a second. This is going to be insane. God, I don't know if I want to do that. Let's just say anything over 5 milliseconds, and then we'll, whoops. Don't do that. Now this is just going to attach, and XFS slower can tell us about all the file operations. The IO operations that took longer than 5 milliseconds. Okay, so this is not what we expect. No, it is. This is your reads. Okay, good.
Yeah.
This is exactly what we want to see. Okay, so are we?
Yeah, because we're looking at the reads and the writes. We should probably just we should filter out just the reads to make it more obvious.
Yeah, but this, yeah, because these writes, and this is actually not particularly great either. This is kind of on the future to-do list. We're just like writing out like 1 byte. Like we should basically do the reverse patch and buffer it. Problem for later. So we've got intermittent reads here. This is what we want to see. But we are, let's see. But our IO weight is still.
I think that's because the level of traffic, we're eating into that IOPS budget just with the traffic, let alone compaction.
Yeah. So we probably need to dial this back a little bit because this read latency is completely like insane anyway. So this filter was already.
Even if we turn compaction off, it's just 3K IOPS aren't enough to sustain.
Yeah, you're right. Oh yeah, because the other thing is that these reads are 1 to 2K every time.
Yeah.
So we're probably, so let's just drop this down. Let's see what happens here when we're at 5K. Let's just take a look. I'm going to switch over to our dashboards because that's actually going to give us a little bit different. Okay, and then there we go. Okay. So we've decreased CPU usage, bytes per second, IOPS. So what are we seeing here? Okay. Are we still hitting? Oops. Okay, so this one's now doing 2,000 IOPS. Reads are occasionally spiking up. Here we're seeing IOPS numbers still floating around 3,000, but our reads are at 34. So are we? The question is, are we behind? Oh wait, I'm looking at the wrong thing. Can't see what I'm looking at. Let's take a look here.
And what's the IP address of the node um, that you put the patch on? Is that .89?
Um, oops. So we've got, these are the ones in the ring. 89 is the one with the patch.
Yeah, so if you look at the bytes read per second, like see how you're zoomed out, see all those red spikes?
Oh
Go
yeah.
down, yeah, that's all the patch right there.
Okay. So we have way higher throughput on this patch. So then,
Yeah.
um,
The problem
so
is
then
that the workload's eating the IOPS budget that we have, regardless of the compaction. That's what's causing the IO weight.
yeah. So we basically have a contention between the compaction and between read performance. So this is definitely kind of a good time to where limiting. So if we were to look at the throughput, the throughput that the control instances are getting, which is only like 30 megs a second. If we were to apply like a 50 or 60 megasecond throughput limit to the node that we is running your patch, we'd still get better compaction throughput, but we should get more predictable latency.
Yeah.
So let's just take a look. I'll switch my screen again. I really need to get this screen thing figured out because I hate jumping between them. And of course, we'll move us up there. There we go. Um, um, what are we getting over here? 30 basically, most of the time. So let's just set this to
Yeah.
64.
On the other two nodes. Yeah.
Yeah. So if we set this to 64, that means that at the most, compaction will take up half of the total throughput limit of the device.
Yeah.
That doesn't seem like a totally horrible decision. And we could, let's just, I'm going to set this here because I don't want there to be any question as to how, like, what kind of a difference, maybe we cheated or something to get good numbers. So I've set it on all the nodes. So now all the nodes have the 64 meg limit on compaction. These are all still hitting their IOPS limits, and they're not even coming remotely close. This one is, so the IOPS here was significantly reduced. It looks like it does spike up here and there. But we're getting what we expect out of that. So we're seeing better numbers. So we're seeing more compaction throughput, and we're seeing less IOPS. Let's take a look at the oops. Let's take a look at my dashboard now. Oops. Nope. Come on. There we go. All right. What is interesting here? Probably the storage engine. We probably want to look at the table side of things. Come on. I know you can do it. Okay. So which one is our which node is this again?
89 is our
89.
patch node, you said?
Okay. Whoa. Oof. Why is 89 the one that's looking unhealthy? Is it doing more?
Or does it think it's down? Because I think it's actually running.
Yeah, I mean, I'm not seeing any errors over here. I am still seeing high IO weight, which is oh, look at that. It's because we're the writer. We're doing we're actually hitting a throughput limit now. We're not hitting the IOPS limit. We're hitting the
on the right
throughput
side.
on the right. The throughput is on the right
Yeah.
side. So,
What if you change the workload to just do reads for a few, since we?
Yeah, we could do that, or we could restrict compaction throughput even further and bring it closer to what this is doing. Because if this is getting only 30 megs a second, then maybe we just change compaction throughput to like 40 megs. So it's going to get the same compaction throughput, but we should see improved read performance on C0, number 89.
Yeah.
What do you think?
Yeah, I mean, let's try it.
Okay, so here we'll just make this quick little adjustment. So I'll set it to 40. We'll apply that to these other two. Oops. And then we'll bring it back. Okay, so this is right about where it was before. Okay, so here we are. This is what we're expecting to see. So we've got reduced. This is reduced. This is still writing like crazy. I'm actually really. It's kind of fascinating how fast, how much different the write performance is. I almost wonder if we need a write throttle. So, oh, I'm not even sharing the right screen. Let's just take a look here. So we've got way more bytes read over here. This is still hitting the IOPS limit. So over here we've got, well, it's still jumping all over the place. But it looks like now that the problem has just shifted to the rights. So we're actually not hitting it. This is actually kind of funny. So if we look here, we see that this is I see what's happened. Okay. So we are hitting a throughput limit now. So before we were hitting the IOPS limit, this isn't even coming close, right? Like this isn't doing it. So if we were to increase the throughput limit here, then we would actually, I wouldn't expect to see a difference on the old nodes, but the one with your patch, I would. So basically, we've eliminated one bottleneck, and as a result, we've basically run into the AWS limit here. So I'm gonna resize these drives. I'm gonna give us more throughput. I'm gonna double the throughput on all the drives, and we're gonna see what happens here. Because the interesting thing here for me is that when we look at this, we see that compaction is taking up less IO, or not less IO, but fewer IOPS. So I would expect that over time, it would do a better job of keeping up, especially depending on the compaction strategy. Like this is just using size tiered. If we were to switch this to LCS, we'd probably be completely crushed. Hold on. Let's switch these instances. Okay. So I keep forgetting the IP. You said it was
.89.
Can I resize all of them at once? No. All right. The max is actually pretty high. You can do kind of a lot. So I think that if I resize this once, I think that's like all I get for like 6 hours.
Yeah.
So how high do you think we can? I wonder what we could use here. I'm just gonna go with 512. I don't feel like resizing.
Yeah, that's what I was gonna say.
Let's go with 512. Okay, so that one's getting modified. Gonna have to make bake volume resizing into the tool. Why not? Okay. So that's done. I don't know how long it's going to take for us to see the effect, but we'll probably notice it when either the throughput increases or the okay. So I look here. I still see that these are limited to 30 whatever megs a second.
Yeah, and we're still hitting that 3,000 IOPS limit.
Yeah. Here we are kind of bouncing around. We're actually not even doing as much here. I wonder if we're just we're all okay. We don't have any compaction left to do over here. Are we behind here, or are we caught up? Yeah, so these are actually behind on compaction. Okay. Let's look at our latency on the cluster. So now that we've removed the throughput as the issue, and as I look at the volume kind of in the background, I can definitely see that it's what is going on here?
It's interesting that 89 has higher latency than the other two nodes.
Yeah, I wonder why. I wonder why we're seeing that, especially since the I/O weight on here is pretty
The one
low.
thing I'm realizing is my patch branch it might need to be rebased if there's any improvement since you built the other one from head. I'm not sure if that's related.
Could be. So it's not technically head plus your patch. It's like head as of a month
It's like
ago.
head
Plus your patch.
from yeah.
Yeah. But still, though, I guess what I'm interested to see here is like this is still maxing out on IOPS. This is still only like we've resized this. Hold on. Okay. So even though this disk can do 512, we're not seeing it. It's in this one either, right? We're literally never getting that.
Oh, you know what? I think those numbers. So I'm noticing that the Axon agent is dead on 89. I think we might need to restart the Axon agent on 89. So we might not be getting real good numbers.
Oh, I think I know what I did wrong. It's because I did use on the host.
Yeah. So the agent isn't actually reporting.
Actually, would it matter? Is
It still needs to wire up that agent.
It's because it's not listed here.
Yeah, like if you do sudo systemctl. Oh yeah, that's right. Because yeah, you're gonna have to copy some files probably.
Mike, what is going on here? All right, what do we need?
You need in so from the 5.01. If you go into conf, there's a axonenv file. Yeah, just the axonenv. We need that in the 50.14542 conf directory, and then restart Cassandra.
Right in there. Just that's it.
Yeah, yeah, and then I would so yeah, do that, restart Cassandra, and then restart the agent.
Oh, boom. Maybe restarting Cassandra. I'm like, what is going on here? These numbers don't match up. I'm like, why are we seeing low IO weight here? The deception. And that would explain why it was like that node's down. Should have.
Yeah.
All right. Cool. All right. Let's see if it's back.
Is it Axon Agent out service or just Axon Agent? I don't think they made it a service. I would just double check their logs. Which there, if you dump the aliases, there's an alias for now.
What am I looking
Yeah,
at?
now look at that latency. Oh yeah, now it's coming back.
Oh yeah, that's
there we go.
That's what we wanted. I'm like, what's going on here? We look like liars. Okay, so we've got way better.
Oh
latency.
wow, that's actually significantly better than I thought it would be. I was a
Yeah,
little bit more
look at
skeptical
that.
than
Look at
you
that
that
graph.
latency.
Look at that
Yeah.
graph.
I want a screenshot of that.
Yeah, man. Here, I'm gonna get this. Boom. Save that forever. Put it on my
Yeah,
wall.
that is actually way better than I thought. I was a little bit more skeptical that latency would be that improved.
Yeah, I mean, going from, I mean, and this is like literally when we just restarted it and got the
Yeah,
new. So this was literally just frozen in time
yeah, that's why
from
that
the last
line's
patch.
so straight. Yeah,
Yeah. So now
so that
we've gone from 1600 and 1300 to 454. Pretty nice little reduction there. So this is above a second,
yeah,
and this is like 400. And then we've got, let's see, let's look at some other stuff because we clearly missed. So load average is definitely less. Average IO weight. Which one are we again?
89.
89. Okay,
Yeah,
so
so
1.8, yeah, 1.18 is at 38%. This one's consistently lower because now it's at 12% and the other ones are at 35%. Pretty
yeah,
nice reduction there. Okay. All right.
there we go.
Yeah. Okay, cool. And we can see here that they're all using right around the same IOPS.
Yeah,
But we've got
I think another lesson here is when you throw a lot of traffic at Cassandra, 3K IOPS is nowhere near enough. Like take the patch, turn off compaction. You're eating through those IOPS.
yeah, we could even stop compaction for a second just to see kind of what's going on here. But even like look at this. Bytes bytes written per second, on our node, we've got it at half a gig right over here. The other ones it's like trickling.
Yeah.
So the other nodes are going
Just
to fall
because we
behind.
freed up all those IOPS for the writes.
Yeah, I'm kind of tempted
Yeah.
to just switch this table to leveled compaction, or just do a major on all three at once, just to see like what the impact is. Um, let's see, is there anything else that we should be looking at here? Okay, so all of them are getting consistent write throughput. I don't know why it shows it that metric like that. Okay. So maybe what we do now, since we know what is going on there, we know that this other one is able to compact way more data, which means if it can handle way more compaction, then it can handle way more writes over time. Like these two right here. Let's look at pending compactions. Yeah, so these other nodes are a little bit behind. I imagine if I were to increase the write workload, which I could increase the write workload. These are not particularly taxed CPU
Yeah.
wise. So I'm just going to go ahead and do that. The funny thing is about this is that looking at the latency, my latency numbers are it's still 500 milliseconds from the application from EasyCast stress side of things. So, but that's only looking at like one node. Like that. Sorry, that's in aggregate. That's not the whole environment. And when we look at these stats, we should see that we're getting better numbers there. Yeah, so on 89, the coordinator read latency is half of what it is on the other nodes.
Yeah, nice.
Yeah. All right. Okay. So a nice improvement there. Let's see. What fun can we throw at this? So if we're not hitting, one of the things about this first workload that we're running is that it actually does like kind of big reads. It's like a time series thing, so that it puts more and more pressure on the system as time goes on. I kind of want to take the nodes 2 and 3 and see what happens from a latency perspective if we switch those. But I feel like there's another comparison or two that we should do first. Oh, I know. I'm going to unthrottle compaction.
All right, let's do it.
So if I just set it to 0 everywhere. Oops. Okay. How about we run? I'm going to run a major. Just going to go ahead and run a no tool compact.
Do it on all 3 nodes.
Yeah.
Cool.
Okay, so I'm just going to bring up system. Okay. Okay, so I've kicked it off on all 3. So we should see the results of that now. Oops. So looking here, let's move us down there. You should see this at the system level. Yeah, so this node is doing like way more. So this should finish a lot faster.
What's the? Can you go back up for a minute to that? Yeah, look at is that blue line the 89 node under bytes read per second, like down under disk statistics and then to the right.
This one?
Yeah, like
Yeah.
yeah. Wow.
Yeah. That is a crazy difference.
That's stark.
Yeah. So basically, we're able to do significantly more there. And let's check out let's see if our latency is impacted by that at all. It might be, because it's unthrottled.
Yeah.
So I think we want to go to. Okay, writes are looking fine. Huh. Oh, I see. Group by host. There we go.
And you're in the 5-minute view, so that was recently.
Yeah, like look at this load average. This one's significantly better. That's way better. I mean, the difference in load average is kind of crazy there. The worst node has load average of oops. Oh, come on. Hope if I knew how to click on things. Yeah, like load average here is at 35 compared to 26.
Yeah.
Overall CPU usage, it's kind of a mixed bag. Like I'd say, like over here, at one point it gets a little bit higher, but that's probably because we were cranking up the compaction, so it was doing a lot more.
Yeah. Yeah. Like more CPU usage isn't necessarily bad if you're actually getting more work done.
Yeah.
And then still that byte thread per second, I mean, you can just see it in the.
Yeah, that is kind of insane.
And it was confusing me for a minute why we were seeing some metrics work and some not with the agent. But what it is the metrics that were coming from Cassandra weren't being reported like latency, but the system level metrics that the agent collects were still being reported. And that's why
Yeah.
that's going on.
Yeah, that makes sense. Cool. Okay. So we definitely are able to chew through a lot more with less overhead. And if we actually capped the compaction throughput, I suspect that if we were to use a workload that was like LCS and a little bit more like mixed, like you see a fair bit of reads, fair bit of writes, we would probably we would definitely, because of the amount of compaction that it does, we would definitely see a pretty serious change there, serious difference between the two, simply because we'd be leaving open enough throughput for the for the readers. We're kind of like, we're kind of like crippling this by allowing it to just go absolutely nuts on compaction. But it's funny, like, looking at node 0, like if I were to do this. So if I'm over here, what was I going to do? Yeah, looking here, it's like compaction's actually using it is going.
You got to move our faces again.
Oh, right. Base over there.
Oh, wow.
Yeah.
And we're still not hitting the IOPS limit now.
Yeah, exactly. So this one's at 23. I mean, occasionally it goes up, but we're seeing like, that's seriously like pretty high.
We just hit 300 megabits a second or megabytes a second writing too. That's I mean, some of that's just opening up the throughput, but just
Oops. So looking here, doing the same thing.
Yeah, I do agree with you that I think like after getting this patch done, the next thing is to look into buffered writes.
Yeah. I think so. It's like it ends up adding up. It's like you don't really need to like push a bunch of stuff into your page cache. You don't need to push 1 byte into your page cache. Like it's a really stupid file system operation to do like 1 byte at a time. So
I wonder too. Well, I guess when you write an SS table, you want it to go into the page cache, right? You don't want to skip the page cache because you're going to end up reading it next. So putting it in the page cache is actually like a good thing, just in the context of like, we've been thinking about direct IO on the read side for compaction, but on the write side, it wouldn't make sense.
Yeah, probably not.
No, yeah, you wouldn't, because you'd end up just loading it back into the cache and making your initial reads of that table slower. But it would make sense to write bigger chunks and reduce the number of IOPS.
Yeah, so we can see here. $3,000 IOPS, 32 megs, absolutely maxed out. 3,000 IOPS, 32 megs, absolutely maxed out. Compaction still running. Over here, 2,400 IOPS, 120 megs on the reads. And
it's massive.
Yeah, that's a pretty serious difference. I'm willing to bet that if I go back over here and what do I have? 2? No. Okay. So looking here, so we started these right around the same time, right? And they have about the same amount of data. This isn't like the most scientific thing in the world, but looking here, I see that we are at 84% complete. And over here, we're at 13% complete. So these are the same exact compaction jobs starting at the same time.
Wow.
So if you're looking at a difference of like an hour versus like a day, and it like affects your latency, this is like
This is a big deal. And sometimes you got to run a major compaction to get rid of tombstones or fix an incident. So
yeah, so if we're looking here, we see our read latency is atrocious. And oops. That's a lie.
Did the node restart? No, it's running. That was an interesting node tool bug.
Yeah. Weird. Did I?
What if you do something else like compaction stats or something like that? Yeah, that's a weird. I'll have to look into that. I don't think that's the patch, but I wonder if it's like because we're on an old head or something, and if there's a bug fix.
Hmm.
Because every other node tool command works, and compaction
Yeah.
stats wouldn't work if the node wasn't running. Wow, that
Truth
compaction's
tables.
almost done.
Yeah, it's like flying, right? So, I mean, when did we? I wish we had time stamped it. I need to. You know what? One of the things I need to do is I need to save every command that was run on these nodes.
Yeah.
This is gonna end. I'm gonna end up having like this is gonna turn into like.
We should make the EasyCast lab put the timestamp and also like maybe color the node
Good idea.
name
Yeah,
in the
yeah, that's a
prompt.
good idea.
I think it
Well,
would
I
make
have.
it pop on the stream more for you.
Yeah, I think I'm gonna set this up with ZSH soon, and I'll make sure I'm gonna use. I think it's called Starship. It's like a really nice kind of
Like
um
prompt designer.
yeah. Yeah,
Oh, very cool.
I'm gonna set that
Yeah.
up. Now I
I've done
want it now.
them I've done them manually before for ZSH. I've never done them for Bash.
So let's just take a quick look. Easy cast stress. Oops. Pull this out. So that's Cassandra 1. And then Cassandra 2. So our read latency and the storage engine side of things, P99 1.1. And let's see. So 900 milliseconds. So the compaction is quite a bit faster. Our latency is a little bit better. Well, 1.3 seconds compared to 900 milliseconds is definitely not trivial. It's still like
Yeah.
over 30% better. So now we're at 700. Oops. So this is definitely jumping around a little bit.
Yeah.
24 SS tables.
P99s are like in the 650s now.
Yeah. Yeah, and this still has a fairly high one. So one thing that's kind of interesting is if as the data set gets larger, like right now, let's see, what are we seeing from? So if I run cache stat,
So reading mostly out of cache.
yeah. Okay. All right, so we've got way faster compaction, which is good. We've got less IO weight over here, also good. We've got, I mean, this is definitely going to be, that's definitely going to be higher. So, oops. Looking at MP stat. I mean, this one is, it's a little unfair now because The other one is completed so much earlier. So like this one has a pretty high IO weight, and we're gonna have to do a cluster versus cluster at some point.
Yeah.
Let's just go back to the. So funny how it's just like crushing compaction jobs. Oh, this one also this one's still set to unlimited. Might as well just whoops. Might as well just cap it at 64 since the other one's never gonna touch that. And see if that does anything for the. These still kill me. Where it's just like going absolutely nuts. Like, no problem.
Yeah.
Fun times.
Yeah. I feel pretty. What are your sort of conclusions so far?
I mean, this is so we have better read. It's better read latency, which we've seen.
Yeah. Significantly better throughput.
Significantly better throughput. I mean, this was also a workload, just strictly on size tiered. So it's like it's a little. We're essentially like the test is more about how fast can compaction go than anything else. And if we were to change this to leveled, which I'm going to just go ahead and do, because I think one interesting test would be to run like the random access workload against this.
Yeah.
And because that's a good workload for LCS. And LCS does just need more it uses more it uses more throughput, right? It uses a lot more IO. So if we were to
just
run
compacting more often.
Exactly. So we would definitely see it have a hard time. Like I think LCS on EBS can be challenging simply because of the throughput requirements. So if I were to actually, if I were to just let's see. I think L10 is what I want. Or let's just, I'll make it like a L4. I think that will work better. So this is the unified compaction strategy. So this will, oh wait, you can't see. So scaling parameters, yeah, so this is probably going to trigger like a whole bunch of work. But I've never taken a size tiered table and altered it to use unified, so I'm not actually sure what's going to happen. So Cassandra 2 says that it has 2 pending tasks. Oops. This has 0. It's good to know. You know, I think we could actually, because right now a lot of this read latency is just coming from the fact that there's like so many SS tables that it's looking at.
Yeah.
I'm just gonna have it do no reads and just kill this thing with writes. So let's just say slow this down, but I'm gonna have it push 50,000 writes a second in through here. And this can be our final test. I know you've got time limitations.
Yeah, I've got probably till noon, so 12 more minutes.
All right. So ramping up the writes. Let's just also, I'm going to just take a quick flame graph and figure out what is going on internally. Let's get a wall clock. Oops. Oh, wrong one. It's probably not even. I wonder how much is coming out of page cache. And this is one of the other interesting things is that the larger the data set, the bigger the impact this has. Large data sets, you end up with like less cacheable workloads.
Yeah.
Oh, we can also should also get our that IO profile. Let me just let's let this thing go. It'll be helpful. What would be helpful?
So you're just throwing like full rights at this?
Yeah, it's currently doing about 46,000 a second. Um, with the express goal of um chain compaction, I guess then it would make sense to unthrottle compaction on this node. Um, oops. So, God, it's funny how fast they're completing. Like now that it's like unthrottled, they're just like
Ripping through.
they're done so fast. Um,
That's
let's
on
see.
the test node with the patch.
Yeah. So this is I'm running our new IOStat plot thing. Oops. I don't think we have it throttled here, do we? No, disabled. Okay, so taking plots, seeing what's up. I'm not even sure if this works. I'm like, it's dicey. It may not. Okay. So now, all right, let's take a look at the let's see. The IOStat thing worked.
The plot. Sweet.
Yeah. Yeah. So let's see. So this is from let's look here. Wait, are these different? They look the same. Oh no, they're not the same. Not even close. Here, let me just share this. I'm not sure which one this is. This is ending in 5. Okay. So which one is this? This one that ends in 5. This is off Cassandra 0. So this is ours. Um, oh, I see. You can see a really big difference. Okay, I know what I'm going to do. Let's bring up Axon Ops because this is actually going to be really apparent there. I wonder. I do wonder how much of this is just coming straight out of page cache at this point. Need to try this with more data as well. This chart still like is crazy.
Just yeah. That's one of the starkest.
Yeah, I think that being able to take full advantage, like these other two are limited to like 25 megs a second, and this one's limited to it gets all the way up to over 200. So we're seeing over 10x difference in drive in throughput at the disk level.
Yeah. Which is phenomenal.
Yeah.
But we've seen latency improve. We've seen disk utilization improve via IOPS, and we've seen our disk read throughput just crush before.
Yeah. So I think that I'll definitely be doing. I'm planning on running some more tests on with this on my own. I'm actually going to also test on an NVMe environment because
and I've done some tests on NVMe, and what I saw was you still see the IOPS win. The throughput wins a little bit less just because you're talking to a disk that has much more bandwidth than EBS. But I think this is overall just a clear win for EBS.
Yeah, I think so too. It's going to be a little bit cheaper for folks, a little bit more reliable, a lot more flexibility in the workloads. I think the LCS thing is actually a useful thing to test, especially if you think about it in the context of like, what if you have a workload that's does a little bit more on the right side, and you're concerned that LCS might not be able to keep up. There, it would with your patch, and without your patch, it wouldn't. So that'll be something to add to the mix. I'll probably just kick that off on my own and see what results I get after this, just to have it running in the background.
Cool.
Since we're already here,
Yeah, might as well.
Yeah, man. Well, I know you got to go.
Yeah.
It's the top of the hour, so I'll let you go, man.
Well, thanks for letting me join.
Yeah, man. Thanks for being here. I appreciate it. I had a good time. It's always fun looking at stats and messing with stuff.
And it's always nice when a theory becomes reality.
Yeah, for sure.
Yeah.
All right, man.
Cool.
Well,
let's get this patch in.
Yeah, bud. All right.
Yeah. All right.
Later.
Talk to you later. Bye.